Hello everybody, welcome back to another session by K21Academy. Today our expert trainer will be talking about how you can install 3-node K8s cluster. So let's get into the video.
Hey there, welcome to another session on Kubernetes, and in this session we're going to talk about how we could set up a Kubernetes cluster using Kubeadm method. And you can follow the steps to install the Kubernetes cluster on Azure using Kubeadm. And throughout this session I will be following this document and I will show you how we could deploy a Kubernetes cluster using Kubeadm on Azure platform. Okay, so let's move on. So as you know that in order to deploy a Kubernetes clusters, we need to deploy nodes, both master and worker nodes, followed by the prerequisites that we need to install some packages like containerd, kubectl, kubeadm. I'll also explain them in the later part of the video. And we will see see step by step like how we could deploy the cluster using Kubeadm method. Okay, so here are some documentations you can always refer, and if you wanted to get a deep understanding of how Kubernetes is being deployed or various methods of Kubernetes deployments, you can go through these links so that you will get some idea on how you could deploy the clusters in various methods on various platforms. Okay, so again, as a prerequisites, as we are deploying Kubernetes on a Azure platform, definitely you need an Azure account. Probably for you guys, you can start creating a Azure free account, and you can also follow the document that you see on the screen. You can use this document to create. You can follow the steps, to create a free account by looking at this document. Okay, so now before we move on to set up, before we understand like how the cluster is being set up, let's talk about some prerequisites, like what needs to be configured before running the Kubernetes cluster. So creating Kubernetes cluster is a matter of running 2-3 commands, that's it. But there needs to be other configuration that you need to configure both on master as well as the worker nodes. And the first and the foremost thing that you come across in day-to-day life whenever you work on any IT platform is that you need to open up the ports. Okay, so as far as master nodes are concerned, so we call them as a control plane node. So master nodes are also called as control plane nodes. And in order to run your master node, there are some ports that needs to be opened on those servers. Okay, that is basically those are inbound rules, and you need to open the port for Kubernetes API server. This is the master service that your API listens, and that runs on port number 6443. And similarly, you should also open the etcd ports that is used to manage your etcd database on the Kubernetes platform, that is from port number 2379 to 2380. And the kubelet service is the main service which runs on all the nodes, whether it is worker or master nodes, that will run on 10250. And then we also have kube scheduler which runs on 10251, and kube controller manager, which is the manager for all the controllers, which needs 10252 port in order to run on the master nodes. So remember, wherever you deploy, whether it is on-prem or any cloud version, you have to open this port, especially on the master nodes or control plane nodes. So coming part to worker node, so there are only two set of nodes. One is the kubelet API server. Again, the kubelet is common for both master and worker nodes. Kubelet is a service which actually triggers sends the commands to the nodes to create those pods and services on those Kubernetes platform. And then the another set of ports is node port, and we call them as high-end ports, starting from 30000 to 32767. Basically, these ports will be used whenever you expose a service using node port method in Kubernetes platform to give access to the environment to the external users. So these are some basic, not basic, these are the ports that you need to mandatorily open both on the worker nodes and on the control plane nodes. Okay, so that is one prerequisite. And then before we move on to the deployment of Kubernetes cluster, let's look at how we could create the virtual machines. So once your the Azure account is ready, you can create VMs, and again I'll walk you through how to create those VMs. But for each VM that you create, you can click on the networking, and the networking you can write the inbound rules. And as this is a test environment, we will open up all the ports so that we don't have to explicitly allow the ports which are defined in the earlier screen, so that we can open up all the ports. But in production, in a production environments, definitely you have to open the ports which are necessary. Okay, so for our lab and for our training, you can open up all the ports, so that you will not have any issues as far as connectivity is concerned. Okay, so moving on. Okay, so how to create a virtual nodes, whether it can be a master nodes or worker nodes. So usually when you are using a Azure free account, you can create only one VM per zone. Okay, so that's the that's the challenge of using a free account. So but if you still wanted to deploy a Kubernetes cluster on a free platform or a free account using your free account, so you can create these 3 VMs in one or more than one zones. That is, you can use 2 zones or 3 zones and create the VMs. And then and the most important point is, if you create the VMs on different zones, each zone will have its own subnet, and every VM will get its own IP addresses specific to that particular zone. So then the communication between master and worker nodes, or worker nodes running on a different zone, might not communicate, because the IPs that are assigned to those VMs are internal to that particular zone. So to build a communication between these nodes which are deployed on different zones, we create a VNet peering. So VNet peering makes sure that the connectivity will be established between these 2 zones, so that the IP, the master node IP, can communicate to worker and vice versa. So that's how the VNet will help in building the communication between the master and worker nodes which are running on a different zones, right? So for that, just what you do is, and in this lab we will try to create 1 master and 2 worker nodes. Okay, so that should be good enough for your practicing, and for for practicing of all your labs for the Kubernetes trainings. Okay, so for the first task, let's create a virtual machines. So to create a virtual machines, it's very easy. Log into a portal and click on the virtual machines, and then you can click on the add symbol here, which will allow you to create the virtual machines. And while creating the virtual machines, you can create a resource group, so that you can tag all the resources in one group, and then you can group the resource group name as Kubeadm, and you can give whatever name you want. But for the sake of our practicing, better try to use the same name, or if you are comfortable, you can use any other name for the resource group. Okay, likewise, if you see, we have given the Kubeadm as the resource group name, and then instance details, you can give the instance details, like what is the image that you wanted to use, the region, the virtual machine name, and the image name you can leave it as default. If you observe, we have given the machine name as master, and then the region is US East, followed by the availability zone options. We don't have to worry about this, you can leave this as default, and image is your Ubuntu 18.04. but again you can use the latest version of Ubuntu as well, and then you can pick the latest version from the drop down menu. And throughout this session, we will be deploying the Kubernetes cluster on Ubuntu platform, right? So then you can select the Gen 1 option for Kubernetes platform, and then you can review and create. Okay, so again you can add the disk, the type of the VM, which is D2S. That's the that should be good enough. That is 2 CPU and 8 GB of memory is good enough for your practicing. Okay, and then you can give a username, password, and which will be used to log into the VMs when the VMs are ready. Okay, and then of course you can open the port 22 because we need to access the master worker nodes using 22 port number, so that you can run the commands remotely. Okay, so next select the disk and networking. In the networking, you can select the the default options. Just let me scroll down. Yeah, in the networking option, what you can do is you can select the virtual networking, and then you can click on the review and create option. Okay, so that's where yeah, and then next the last screen is to review and submit the VM creation template. Okay, so once the VM is done, then you can click on the VM and then go to the networking of the VM, and under networking you can click on add inbound rules, and in the inbound rules you can open up the inbound rules for all the ports. If you observe, source is the source can be any source, and the port range is star, that is 0 to whatever port that you want. Destination is any source, any destination on any port is allowed, and you can name it whatever name you want with the inbound rule. Here we are using port underscore all, and then click on add. So that will add the that will enable the ports, okay, on this particular master node. Similarly, once the master node is done, you follow the same method, create the worker nodes. Okay, so in the worker nodes, again go to the virtual machines, click on add, and then click on the instance detail, give the machine name as worker1, and here for the region we select the South Central US, because previously we have used the different what you call region, which is US East. Okay, so as we have a limitation for the free account, for the worker nodes try to use the different domain. In our case we will be using the South Central US. Okay, and then create a resource group which is Kubeadm, and then mention the region, worker name is worker01, and then leave the Ubuntu as it is. Okay, and then again use the same machine type, which is D2S, that is 2 vCPU and 8 GB of memory, and then give the Ubuntu username and password for you to log into the machines, and then allow the inbound ports as port 22, so that you can connect to the servers remotely. And then again in the networking, you can create a virtual networking. You can call that virtual network as Kubeadm VNet 485 or whatever name that you wanted to create, and then click on review and create. Okay, so and then finally you can click on the create button. Okay, again same procedure, you can click on the worker node, then go to networking. Under networking you can add the inbound rules, and you can open all the ports on that particular worker node as well, like similarly what you have done on the master nodes. The only difference between two steps is worker node is in US East region, master nodes are in US East region, worker nodes in US South Central, because there is a limitation on the free account. Apart from that, VM creation, port allocation, disk allocation, instance type, everything is same. Okay, and again same process you can follow for the worker node 2 as well. So you can click on the VMs, click on the resource group, create a resource group, machine name as worker2, and the region is South Central US, and then similarly give the instance type. You can select the same instance type and give the username and password for us to log in, and enable the port 22, and then similarly you can use the same VNet that you have created, use Kubeadm VNet 485, so that later we will use this Kubeadm VNet 485 for our VNet peering. Okay, and then once the VM is done, you can again click on the VM and enable the ports on that particular worker node. Okay, so the process is same whether you create one node or 10 nodes, create the VM, select the region and select the instance type, add the storage, and then once the VM is done, open up the inbound rules. In our case, we have opened up all the ports. So that's common for all the 3 nodes. Okay, so now if you observe, we have 3 nodes, master and 2 workers. Master is running on US East and workers are running on South Central US. Right? So now the VM creations are done, and the next thing that we need to work on is creating a virtual network peering, because these VMs are running in a different regions. We need to build a communication between these 2 environments or networks so that master and worker nodes can talk to each other with the help of VNet peering. Okay, so what we can do is in the search bar you can search for virtual networks. Okay, and in the virtual networks okay, so search for the virtual networks, and then in the drop down select the master virtual machine, and when you click on the master virtual machine you will see a overview section. In the overview section, go for the peering and click on add. So if you see, when you click on the MasterNode virtual networking, you can see that you have a peering on the left side. Click on the peering, and then on the right side you have an add option, so that you can create a VNet peering between these 2 environments. So once you click on the add, you need to give the following details, the peering link name, give a name, whatever name that you like, which is in our case it's Kubernetes-peering, and traffic to allow remote virtual network, choose allow, and traffic forwarding is choose allow, and virtual network gateway is choose none for the default. Okay, so virtual network, you need to use the Kubeadm VNet 485. That is the virtual network that we have used for creating the worker nodes. Okay, so if you scroll down, you can see this is the name of the VNet peering, allowing the virtual traffic and traffic forwarding, and then finally you will use the VNet peering, and then you can click on the submit option. So here in this virtual networking option, at the drop down you need to select the virtual network that we have created at the time of worker nodes. Okay, and then click on add. Now click on add, and then the VNet peering status is showed as initiated, and it will take some time for it to build a communication between these 2 zones or regions. Okay, so once the peering is established, you should see a connected status in the VNet peering. Okay, so and then you can test the connectivity of the machine IP addresses by pinging each IP addresses from master to worker and worker to master as well. Okay, right. So that completes the VNet peering. So this is pretty much straightforward. Create VMs. Of course, you have to do this VNet peering only if you're working on a Azure free account. So if you have a properly pay-as-you-go account, you don't have to do this VNet peering. You can create all the 3 VMs in one zone, and when you create the VMs in one zone, you can ping to those machines, because they are in the same region. So if these VMs are running on a different region, then you can create a communication between those 2 regions using a VNet peering, and create the VNet peering as we have seen in our previous slides, and then you should be able to communicate. So the thumb rule here is your worker nodes and master nodes should be able to communicate to each other. Okay, so those are the prerequisites that you need to consider as far as Azure is concerned before deploying the Kubernetes cluster on top of those VMs. So now let's get into the actual Kubernetes installation topic. So here now the thing is, we need to log into the master worker nodes, because we need to run the commands on both the nodes. Okay, so you can click on select the virtual machine, and you can click on the master, and you should be able to see the public IP address of the master node. Similarly, you can copy the public IP addresses of your both the master nodes as well. Okay, so and then log into the public IP address with the credentials that you have given at the time of creation, and then log into the machine and get the escalated privileges using sudo -i, and you should be able to log into the machine as a root user, because in order to run the Kubernetes cluster, or in order to create the Kubernetes cluster, you need to have a root privileges. Okay, so in my case, I already have my Ubuntu machines ready, where these machines are running on a Azure platform. I have logged into the machines. I have logged into as a root user, and these are the VMs running on the Azure platform. So I've logged into master and 2 worker nodes. So from here, we will try to configure the Kubernetes platform.
So guys, this was our expert from team K21 Academy, and if you want to have a step-by-step guided blog, then you can check it out at k21academy.com/Kubernetes 30 that covers all the topics discussed in a step-by-step manner. Also, if you want to have a deeper dive into the topics discussed, then we have something really special for you. We have our free class on Docker and Kubernetes certification to get higher paid jobs. Under this free class, we'll be talking about why learn Docker and Kubernetes, Docker container architecture, image and containers, what is Docker and why to use it, and every topic that will help you have a deeper dive and basic concepts are cleared. So you just have to visit k21academy.com/K8s02. You'll be seeing this kind of interface. You just have to click on book your free seat now, select your event date, add your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be seeing this kind of interface and this link on the extreme right. You just have to save that link, add it to your calendars, and I'll see you in the next part. Till then, take care and keep learning.